Thank you, everybody. I'm Andy Zimbalist, and this is Ben Balmer. I had the good fortune to have my name and my biography already included in some of the programming that you got. Ben didn't, so let me briefly tell you that he's currently a colleague of mine at Smith College in the math department, and he spent the last 8.5 years working as a sabermetrician for the New York Mets. Those of you who are Mets fans and have thought all these years that the problem of the Mets was Bernie Madoff and Jeff and Fred Wilpon, let me disabuse you of that notion. You can direct all of your animosity at Ben over here.
Take it. Take it.
All right, so we've just finished writing a book that's called Moneyball Revisited. And I think it's fair to say that what motivated us to write the book was to do something that we don't think has been done before, which is to turn the tables on sabermetricians. Sabermetricians and metricians, or people who do analytics in all of the sports, are busy analyzing the performance of others. We wanted to analyze the performance of sabermetricians, and I'm going to say a few words to you about that, and then Ben is going to describe in more detail a particular part of our research. But here's an outline of our book. We start off really just looking at where it all began, or it didn't really all begin there, but the popular interest in Moneyball, and certainly industry-wide interest, began with the book and the movie. So we talk about what we see as the misrepresentations and inadequacies, and also the kernels of truth that are in the movie and the book. Then we go on and in the next chapter talk in some detail about the introduction of analytics personnel into the front offices. Chapters 3 and 4 are our attempt at an overview of the development of sabermetric thought over the last 15 years, although we go back longer in history in our review. And we look at some of the debates and ongoing controversies, and also add our 2 cents about what we think is still problematic about sabermetric thought and what needs to be done. In Chapter 5, we talk about the application of Moneyball outside of baseball. We talk about its diaspora to the other sports. I think here the 2 distinguishing features are, number one, that the other sports, of course, are less discrete and more continuous than baseball is, and that the production of the game is much more interdependent, much more cooperative than it is in baseball. And the other aspect of the development of analytics in the other fields, of course, is that with baseball we have a long history that goes back to F.C. Lane or Chadwick, and it goes through George Lindsay, and it goes through Earnshaw Cook, and lots of people all the way up to Bill James in the 70s. And then we have 2 or 3 decades of Bill James and his followers developing baseball analytics, developing sabermetrics in the open broad daylight without any worry about the proprietariness of it. Then, of course, Moneyball comes along, shifts the culture, and the other sports get interested in doing analytics, but the practitioners are quickly absorbed into the teams, or the leading practitioners are absorbed quickly into the teams. And so the development of analytics outside of baseball doesn't benefit from decades of open sourcing, open public discussion, and sharing of information. It right away gets absorbed into pretty much a black box. And I think both of those characteristics about the nature of the production function outside of baseball being different, and the timing of how analytics and when analytics develops has made the evolution of analytics more halting outside of baseball. Chapter 6 talks about a particular issue in baseball, competitive balance and revenue sharing, and it uses analytic techniques to evaluate the different collective bargaining agreements over the last 15 years and the kinds of incentives that were created or not created that either promoted or did not promote competitive balance. And chapter 7 is really the guts of what we set out to do. And let me just very briefly talk to you about how we went about turning the tables on sabermetricians. As I said in Chapter 2, we tried to identify the incorporation of sabermetric personnel into the baseball front offices. The problem with trying to say, okay, here's a team that has 2 sabermetricians, and here's another team that has 7 sabermetricians, and here's a team that has 0 sabermetricians, and saying, okay, now we have an index, we can see how sabermetrically oriented each of the teams are. The problem with that is that we don't know when a team says it has a sabermetrician what that person does. We don't know, maybe they have somebody doing analytics, but they're not called an analytic person. We don't know, even if they are doing it, whether the GM is listening to it, and whether, if the GM is listening to it, whether he's able to implement the suggestions. So it doesn't make, in our view, it didn't make a lot of sense as we tried to figure out how sabermetrically intense different teams were. It didn't make sense to look at personnel. It would give us a lot of noise and not a very good reflection of the sabermetric application in the different teams. So instead, we set out to develop a metric of sabermetric intensity. And the way we did that is to identify what we consider to be the key sabermetric insights that have evolved over the last 10 years or so. Each of those insights corresponds to a particular measurement. So that, for instance, one of the most basic is on-base percentage is something that's more important than batting average. So part of our index was to look at the outcome of each team in each year, the ratio of on-base percentage to batting average. Another sabermetric insight is the importance of defense. So we use the defensive efficiency ratio relative to fielding percentage for each team. We use fielding independent pitching, again, relatively as a metric. And we use ISO, isolated power, relative to slugging percentage as a metric. We have other metrics that correspond to strategy issues, such as on-base percentage and sacrifice bunting. So we have a variety of components of a sabermetric index. And of course, we do park adjustments, we do league adjustments, we normalize our different components, and then we weight them according to how important they are as predictors in a multiple regression, as predictors of team winning percentage. And through that process, we develop a metric for each team in each year between 1985 and 2011, how sabermetrically intense that team has behaved. Having done that, having developed a sabermetric index, we then do a regression of team win percentage on team payroll and team payroll squared in order to take out the effect that payroll has on team win percentage, because from that regression we take out the residuals, and then we use the residuals to run a regression of the residuals from the win percentage and payroll equation on our sabermetric intensity index. And what we found is that approximately 44% of the variation in the residuals is explained by the variation in our saber intensity index, which is a very salutary and encouraging, I think, result. The two caveats to that result are, number one, we're looking at a period of time, I think, when many of the years were characterized by low-hanging fruit. It was pretty easy in the early going to say, okay, walks are important. Okay, defense is important. Okay, dips or FIP is important. As we've proceeded, as more and more teams are starting to assimilate these practices, and we've proceeded to the present, it's much more difficult to develop those insights. So the fact that I think we have adequately and interestingly made a good argument that says sabermetrics has been productive over the last 10 or 15 years. Whether that can continue into the future is largely an open question. So that's caveat number one. Caveat number two is that really, I think a proper reading of Lewis's Moneyball is not just, the book is not just about sabermetrics, but the book is about competitive balance in baseball. It's saying that you can have a poor team, a small market team, if they're smart enough in the front office and do the right things, they could overcome the fact that they're small market. Well, this raises the question of the adjustment process that goes on within the game. Because whereas somebody might have had a great insight in the late 1990s about on-base percentage, Sandy Alderson had that insight and he incorporated it into the practice of the Oakland A's, over time other teams began to incorporate that too. So what happens in the marketplace is that the valuation of these sabermetric insights or sabermetric skills changes. And one of the things that can happen is that something that was overvalued in the past can become, something that was undervalued in the past can become overvalued in the future. And that leaves you with another conundrum, which is that if some sabermetric insights are now overvalued, whereas they before were undervalued, then some inefficient, recalcitrant GM who still is using none of the new techniques might have an advantage over people who are overpaying for a sabermetric skill. Anyway, that second caveat is a lead-in to the second part of our presentation. Ben is going to discuss in much more detail how we tried to look at the labor market adjustment process.
Okay, so I'm going to walk you through part of what we present in Chapter 7. So the idea, as Andrew suggested in this case, is we're trying to understand the baseball labor market. And there's two components to that. So the first part is trying to understand what translates into teams winning, okay? And so to do this, we built a model that is an extension of something that was published by Hakes and Sauer in 2007, where, again, we're trying to predict team winning percentage, and we're trying to do it as a function of three explanatory variables in this case, which are almost independent. So we're trying to capture three basically mutually exclusive batting skills. So in this case, we'll be talking about I, and that's just walks and hit by pitch per plate appearance. Bat, which is batting average, and power, which is slugging percentage divided by batting average. Okay, so these things go into the model, and the model is constrained in such a way that, so for one thing, we're looking at deviations from 500, so winning percentage greater than or less than 500, and we want, so because we're looking at winning percentage as opposed to runs scored and runs allowed, we want equal contributions from a team's offense and defense. So these are the constraints, and so this is what the model actually looks like. And what we can see is that this model works pretty well, so that we actually end up keeping in mind that we're analyzing both offense and defense at the same time. We're able to predict 88% of the variation in winning percentage using just these three variables. And I think if you think about it, you would expect this, right? Because there's a lot of other things going on in baseball, but this captures a lot of what's happening. Okay, and so the results presented here are just for a year, but you can do it, as Andy said, we're going from 85 to 2011, and you can break that up in any way you want. And one thing that I'm going to talk about is how the value of these coefficients change. So would you expect that these coefficients would remain stable over time? Does it make sense that these things would fluctuate wildly? I don't think so, because as much as baseball is a dynamic game that changes over time, and the players change, and sometimes the rules change, most of what the game is kind of stays the same. And so you would expect this relationship between these three quantities to kind of be relatively stable over time. And so what's being plotted here are the value of these coefficients year by year. So we're looking at the net change in winning percentage on the y-axis. This is the value of the coefficient. And each one of those dots represents one of those coefficients over time. And what you can see is that there's not really any long-term trend here. Okay, so we don't see things changing all that much. And I think this makes sense, right? Because baseball, in its heart, is a relatively stable game. Okay, so the second part of that, though, so now we've understood something about the way that these variables affect how teams win. And the second part of the question, then, is how are these skills valued on the labor market? So how are players compensated for their contributions with these particular skills? And unfortunately, in this case, the model is a little bit more complicated because the salary structure in baseball is a lot more complicated, right? So there's lots of rules. I know there's some people in the audience who can probably talk all day long about, arbitration eligible players and free agent players and how the salary structure goes, and it all gets unbelievably complicated. So in addition to the same three things that we were talking about earlier, there's a bunch of other variables trying to account for some of the fact that these salaries are not free market. They don't get assigned every year. What we're actually building this regression model on now is the log of player salary, and it's being regressed against the value of these variables for the same player in the previous year. Okay, so the salary in this case is thought about as a response to what the player did in the previous season. Okay, so what happens with this? So we get a more complicated model. It's not quite as effective or not quite as accurate as the one we had before, but it's still, pretty good. And so now we want to think about these coefficients. So would we expect that these things would change over time? And this is part of what the original authors, Hakes and Sauer, were trying to get at. And so you can kind of see it's a little bit grayed out there. But Moneyball was published in 2003. So it was written about the 2002 season. book was published in 2003, and the question that we want to ask ourselves here is, well, was the return to, let's say, batting eye in this case, so walk rate, essentially, did that change after the publication of Moneyball? And this was the original conclusion by the authors, and you can see some evidence for this, right? So the green line on the bottom, you can see that the return to power, it didn't change at all. It hasn't changed, give or take. In a long-term trend, it hasn't changed. But immediately before Moneyball, you can see that the blue line kind of spikes way up. And then afterwards it goes back down, and where it's headed in the future is kind of unclear. But this is some evidence that there was some kind of market correction here, where this particular attribute was probably not quite as highly valued on the labor market as it should have been, and that changed, basically right around the time that Moneyball was published. But it started before that, right? So it started just before Moneyball, because there has to be some kind of lag effect, right? People have to read the book actually after it comes out. And so it seems as though around the time that the Moneyball season was actually happening, this is when things started to change. Okay? All right. So the next question then is, well, how can we understand how these things are related to one another? And so to do that, we constructed a similar model. So now we're looking at different periods of time. There's a lot of random variation in the things that we've seen previously. So now we're looking at things in larger blocks of time. And now we're taking logs on both sides, because we want to look at, so what the economists would call an elasticity model. We're looking at how the percentage change in one variable affects the percentage change in the response variable. And what we can see is that, again, this regression is telling us a lot of information. So we're getting the changes in salary, now we're looking at offense only. We're looking at the percentage change in runs scored as a function of the percentage change in these three other variables. And then, so we want to do the same thing now with the labor market valuation. So again, same model. Now we're taking logs on both sides, and we're looking at how these percentage changes in each one of these variables creates a percentage change in the explanatory or the response variable. So those coefficients on their own are a little bit hard to interpret. So we're looking now at how they're related to one another. So dividing one by the other. So the 0.41 here for I from 1985 to 1997, where is this coming from? So this is the 0.11 here divided by the 0.27 here. Okay, so it's the relative return to this skill. And what we can see here is that the relative return to batting average hasn't changed at all. So however that's being compensated on the labor market in relation to how valuable it is to teams and actually winning games on the field, that relationship has not changed at all. But what we do see is that the relative return to I, so this notion of taking walks and grinding out at-bats, this changed rather dramatically in the period immediately after the publication of Moneyball. Now since then, it's come sort of back to earth a little bit, and where this is headed in the future, I don't know that anyone really knows. But again, so you see some corroboration of the story here that before the book was published, you have this kind of market inefficiency, and there's some evidence that that changed in the period immediately following the book, but then perhaps there's been some kind of overcorrection since then as this thing has come back down again. Okay, should we go through the?
Sure, go ahead.
Okay, so Andrew alluded to this earlier, but we're talking about, so shifting gears a little bit, how can we try and answer the question of whether sabermetrics has worked or not? And so as Andy mentioned, a simple model for winning percentage as a function of payroll only explains about 22% of the variation. So there's some 78% left over that is not explained by payroll. And I think this is what we'd expect, right? Baseball's a complicated game. We know money counts for something, but it doesn't count for everything. So what can we say about that remaining 78%? And the idea is to, as Andrew suggested, come up with some way of measuring how much teams are employing sabermetrics. So how are they using it? And again, looking at personnel is not really necessarily the best way to do that. But looking at the data itself, can we figure out, based on actions, what people are actually doing? And this is hard. So this is a hard question, and unfortunately, we don't have a clear answer, but we have something. So this is what the model for payroll looks like if you try to. So each one of these dots represents one team in one season. And you have winning percentage on the y-axis and the relative share of payroll. So payroll relative to league average on the x-axis. And this is the quadratic model that we fit. So, you see something there, but it's not really that great. Right? There's a lot of variation that's unaccounted for. And the three lines that you see are after putting in year effects and team effects, the green line represents the model for Oakland. So this was the highest team effect. And the Yankees are the one in navy blue, and the Orioles, which have the lowest team effect, are at the bottom. All right, so one of the observations that we made, and Andrew alluded to this as well, is that the A's, for whatever reason, have had a park-adjusted, league-adjusted on-base percentage that is, so relative to league average, relative to park, greater than their batting average, team batting average, in 14 of the last 16 seasons, or whatever it was. So I actually think it's, 26? So 23 of the last 26 seasons. Okay, they've done better at getting on base relative to hitting for average. Right? Now, is this a coincidence? Probably not. Right? So probably, as we know, they value on-base percentage more than they value batting average. And here we see evidence, empirical evidence, that we can say, okay, they're actually thinking about this and employing it. And this was the idea behind the sabermetric index that we built, was to try and identify a bunch of things like this. So this was one. This was kind of the most obvious. But we don't have time to go through the whole thing. But there's 5 or 6 other things that are built along the same kind of idea behind this. So this we kind of already talked about. In the end, so after we construct this index, so we can explain about 44% of the remaining 78% of those residuals using this sabermetric index. And that suggests that beyond money alone, the employment of sabermetrics is helping these teams win, right? So again, I think this makes sense. The question is how much? And when you look a little bit deeper at some of the individual teams, what you see, so you see several important true positives, right? So we know teams like Oakland and Boston, the Yankees are doing this, and they score highly on this index, okay? So this makes sense. We know that Tampa Bay, in the era before Andrew Friedman became the GM, were not thinking about this, and they score very low. But then, since then, they score very high. Okay, so this lends some credence to what we're doing, that we're capturing these true positives. There's also some other things that maybe don't quite fit as well. So teams like Atlanta and Philly also happen to score very highly. Now, we don't know, I guess, but we suspect that these teams are not really doing a lot of sabermetrics, right? So, is it the fact that they know something that we don't, that they're not telling us about? Or, are we just not capturing exactly what's happening here? So we don't know. There's some perhaps false positives. And so the work that we have is, it's a start. So it's a difficult question to answer. And I think we have a start. We have some evidence. But there's certainly a lot of room for open questions. So that's it for us. Thank you.
And speaking of questions, we have time for some. So let me grab the mic here. And if you just raise your hand, I'll bring you the mic if you have any questions. Go.
So you did most of this analysis using residualized, the residualized effect after taking out payroll. But wouldn't you expect some correlation between payroll and the use of sabermetrics and some of these other covariates that you're putting in there? And so I was wondering why you went with that specification rather than just putting it directly in the original regression and then backing out the effects afterwards.
Yeah, I think, so this is a good thing to think about, actually, and I've thought about this. I think so we want to start with something simple, right? And so as Andy said, one of the themes of Moneyball was about overcoming this, the fact that Oakland didn't have money to spend, right? And so this is the beginning. And so the question is, what can we say about how teams are overcoming that, not having money? And so that's where the team effects come in, and that's where trying to explain the residuals come in. So, do you have anything?
Wait, so I'm not sure I understood the beginning of your question. Are you suggesting that if you're a rich team, then you have more money not only to spend on your players, but to hire sabermetricians? And that's why you would expect a correlation between payroll and sabermetric intensity?
Yeah, I think the residualized approach is, like, your specification is going to get you the same estimates as long as there's no correlation between payroll and any other covariates you throw in the second stage regression, right? But if you would expect any correlation, you'd probably want to put it in the first stage and then just back out the effects directly from that. And I think you're right. I would probably, I imagine there's going to be some correlations, it's probably an interesting U-shaped relationship where the really poor teams may invest heavily in sabermetrics and the rich teams may have the resources to do that as well. But you'd probably want to account for that relationship in doing your regression, because otherwise your residuals are going to be biased.
Yeah, it's a good thought.
I think it's an interesting hypothesis that there's a U-shaped relationship. I'm not sure that it's true, however. So to the extent that your suggestion is correct, then the method for correcting it is an interesting idea for us. Okay. Yeah.
And you could always check that.
By the way, I think some of you are aware of this. It doesn't cost very much to put together a sabermetric department, right? You have some people getting paid $40,000, some getting paid $100,000. Maybe some people who've been around for a while who previously were associated with sabermetrics and have gone to become head of baseball ops or something like that. They might be getting several $100,000. But the core people who are doing the analytic work, and most teams have 1, 2, or 3. A couple like the Rays might have 6 or 7. But so you're talking about an investment of a baseball minimum salary at the most, $490,000.
Thanks. So just a question about the structure of the labor market and the way it tends to react to new information or new ideas as it comes about. And perhaps you could draw on experience in other sports or other fields as well. Is your idea, or does your research suggest that the sort of natural long-run state of the pricing of various components of player skill in some hypothetical, abstract, perfectly competitive environment, would it naturally be stable from year to year, and so these moves suggest some sort of inefficiency, or is it some sort of dynamic equilibrium where you would expect the prices to go up and down around some long-term value as the fact that as teams bid up one skill, which makes another one undervalued, and so you'll be constantly going back and forth as you correct and counter-correct, and there'll be no stability?
Right. You want to take it, or should
I'll start.
Go ahead.
You can finish. Yeah, so I think this is the big open question, right? So like, how much does this change? Certainly there's fluctuation from year to year because there's different free agents on the market. Teams have different amounts of money to spend, and sometimes the rules change, and yeah, so there's all kinds of reasons why you would expect to see that fluctuation.
And autocorrelation of skills isn't equal to 1.
Right.
But yeah, but are those? It's a good question, and I don't know the answer. Like, are they fluctuating around some relatively constant number, or is there some kind of long-term trend?
And then in theory, if you're just designing a model of this from scratch, would you expect there to be big ups and downs around some average as teams compensate, or should it be so perfectly competitive that everybody will offer the exact same amount for every skill in a perfect market? Always.
That depends on the amount of information that's out there and how people process the information, doesn't it? I think one of the reasons why, Ben showed you first the chart where where the return to the skill of eye or walk rate shoots up begins to shoot up in 2002, and then it shoots up a lot more in 2004. So it seems like there is new information in the market. One of the reasons why he showed you the second set of tables was because it's very hard to look at a year-by-year fluctuation for the reasons that you're suggesting, Dan, and make any conclusive inferences from that. So we're looking at periods of time, and I think if you looked at these blocks of 5 or 10 years, you do see movements that are holding over a longer period of time, and they are suggestive of corrections going on in market inefficiencies.
And how do you choose those time blocks?
Well, that's a good question. I think that some of the time blocks were motivated by Hakes and Sauer, and Hakes and Sauer are motivated by trying to look at the impact of the book Moneyball. And we might, I'm not sure, we might have tweaked it a little bit by a year in one direction or another. I don't remember exactly.
I think we did.
Yeah.
Andy and Ben, thank you so much.
Yeah, thank you.
Thank you.